In this video, we're going to look at a situation in which the upper and lower curve, either one of the upper or lower curve actually changes in an interval, and that's going to kind of cause a little wrinkle in the way we approach these type of problems. But then I'll offer another way you can view it, and so we'll do this problem in at least two ways. So the first thing to do is we got to graph x equals y squared and y equals x minus 2. So x minus 2 is just a line with a y-intercept of -2 and a slope of 1. And x equals y squared is a parabola that opens to the right. So I'm going to just stop it here because we can see, the area that's been trapped is this area I'm going to sketch in pink. This is the area we see is trapped in between those two curves. So let's go about this as though we're going to integrate with respect to x. So I'm going to write with respect to x approach. So in order to do that, we need to describe the functions in terms of x. So y equals x minus 2 is done, but the curve x equals y squared is not expressed as a function of x, of x. So in order to do that, we got to solve for y. So if you square root both sides, you get y equals plus or minus the square root of x. And the plus or minus is indicated in the graph because if we want this to be a function of x, we actually have to view it as y equals this positive square root of x, which is this top half. So I'm going to write that as y equals the positive square root of x. And then the bottom half here is y equals the negative square root of x. And so now, if we're setting up our integral, we're thinking top minus bottom. So I'm going to just draw a vertical rectangle there to represent, one rectangle whose area we'll be finding. So we're going to integrate as x goes from 0, and then you'll notice that the top function is always the square root of x, but the bottom function changes right at x equals 1. So I need to stop this at x equals 1. The top function up until this point, maybe I'll emphasize it more. So the top function up until that point is square root of x, and the bottom function is the negative square root of x. So minus negative square root of x. So that gives you that black area there, but then you need to add that to the integral from 1 to 4, and this time the top function is still square root of x, but the bottom function is x minus 2. So here's a situation where the lower curve changes on the interval, so you need to break this up into two integrals. There's no way to do it in just one integral. However, there is if you decide to switch perspectives and say we're going to integrate this with respect to y, and then we're integrating sort of from the bottom upwards. And the quote top function is actually the one to the right, and the bottom function is the one to the left. So I'm going to indicate that with a green line, I guess. So in this case, if you just think of this green line and imagine this green line kind of swooping through and getting all the area, right? Your rightmost function is always the blue line, which we need to express in terms of y. So that's if y equals x minus 2, then x equals y plus 2. That's what we want to name this blue line if we're integrating with respect to y. And again, the parabola, the red one, we should name x equals y squared. And then therefore the actual integral is going to go from our y values -1 all the way up to the y value 2. And the rightmost function is y plus 2. And the leftmost function is y squared. And that doesn't change in the entire y interval -1 to 2. So this might, arguably maybe more elegant because you don't have to use two integrals, but either one of these would be acceptable and they should both return the correct area.